Hello everybody, my name is Colin from TFDi Design. I'm here to show some progress updates on our upcoming MD-11 project and hopefully get everyone on the same page. So, it's been a little bit since we've posted anything outside of our Discord, which we do recommend you join for more up-to-date announcements and updates, but I'm going to bring some of those updates here today. So for many of you, this will be the first time you're seeing the aircraft actually in Microsoft Flight Simulator, which we are here. We actually have it working in Sim. Everything's off right now, but we'll change that here in a second. So, going throughout the cockpit, you can see that there's quite a bit of texturing and detail. It is still very much a work in progress. However, we are toward the later end of development on most systems, including the texturing and cockpit modeling. So, without further ado, let's hit the external power button here and get some light on. Actually, no, you know what? Let's do it with the battery. Now we have the startup process a little accelerated, so obviously it would take a little longer than that. But for the moment, it starts up relatively quickly. Now, as you saw the screens fade in, that is not just a visual artifact. We actually simulated that to try to simulate the warming up of the CRTs. It's hard to find exact reference for what that looks like, but we've attempted it at least. Continuing on, let's go ahead and push the external power button here. Get some power on here in the rest of the plane. Switch over, make sure we recycle this to get emergency power to turn back off. So, immediately, you're presented with all 6 screens now. This is something that we didn't have in previous development updates. We're going to kind of go through a list of the systems overall here and give a quick status update with what I can show here in MSFS. So first and foremost, the FMC has come quite a long way since its early design. We have the majority of its systems implemented, including the Magenta line. So I'll go ahead and punch in a short flight plan here. We're not going to spend the entire time doing it like you would for a full commercial flight, but we'll get something in there. You can switch the captain's ND over here to map mode. So there we go, we have that in there. Let's say we'll put in a star as well. There you go. We have holds. You can see through these turns here that we do have turn calculations. The best part is all of that is not just visual. The FMC actually knows where it's supposed to be, which brings me to the next part of the discussion here. Autoflight. It needs to be retuned for Microsoft Flight Simulator, as, of course, the flight dynamics are quite different than P3D. However, functionally, it's pretty far along. We have all the standard modes you'd expect, like altitude hold, vertical speed, flight path angle, speed mode with the auto throttle, so on. So we have the LSAS and the roll control wheel steering, known as RCWS. The latter was an option on certain aircraft, but certain carriers could opt to have it installed. The LSAS system provides pitch stability assistance to the pilot to avoid with overly rapid pitch changes, to help avoid tail strikes, and to provide better landing performance. We have this system implemented. I won't be able to demo it here today because we'll focus on that in another video. But the autoflight system itself is very robust and is quite complex, especially given the era of this aircraft. Let's talk a little bit about the onboard systems now. So we have the electrical system and the hydraulic system more or less complete. The fire protection system is pretty far along. The flight controls and FCC system are pretty far along, as well as the FADEC and engine controllers. The easiest one to do a deep dive on right now will be the electrical system. So if we look at the overhead, we see that we have all these buttons with the lights out. There are some lights like these that are on right now that shouldn't be. These are minor issues. This is a work in progress copy of the aircraft. But let's zoom in on the electrical panel here. So, as you saw when we started the aircraft, we hit the battery button, we got power on some of the buses, and then we used emergency power to get the rest of the way on. The electrical system in the MD-11 is quite complex. If you look at the electrical synoptic display, you can see that the AC and DC buses are indicated as well as their load. If you have generators on, you'll also see the frequency and voltage of those power sources. In this case, we're running off of external power. At a glance, you can see that there are some numbers indicated next to the load. Those are real numbers. Whether or not they're 100% realistic with the actual aircraft, it's very hard to tell, given that without measuring the electrical load of each individual component, it's kind of hard to know exactly what it draws. However, our systems simulate distribution of power load throughout the electrical circuit. So this is not just a case of if battery on, then things are powered. It's much more complex than that, and the reason we did that was not only to get it right, but also to allow failures. So for example, if I go to the overhead and we switch the elect smoke air system, you see we've now lost system 3. We now also have lost some of our displays. We've had to reconfigure, and now we have a whole slew of alerts on the SD. We can go ahead and recycle that back around. As I do that, you can see each bus begins to come on and off as its respective system is isolated. Now, we've also triggered emergency power here. Because of this, in order for it to turn back off, we have to recycle the switch to off and back to ARM, much like the 717 for those of you that are familiar. This electrical system that we've created also allows us to simulate breakers and individual component failure. As part of the extended simulation package, you'll have access to some circuit breakers and further more granular failures. The rest of the systems are simulated to the same degree of fidelity. The hydraulic system is complete as well. Although this light is on right now, the hydraulic system controller is actually working. So if we start pushing buttons, it won't do a lot. However, if we switch it to manual mode, now we can control things. If we switch the synoptic display over to hydraulic, you now see we have this transfer pump on. If we turn that off, you now see that the pump indication is white, meaning that the transfer pump is no longer functioning. If we were to turn off System 2 pumps, you'll see the pressure light illuminate, the off lights illuminate on the pump, the appropriate alerts display on the synoptic display, and you will see the pressure on the system drop to 0. But let's push the auto button back on. Let's let it fix itself here. Now we're repressurized. Speaking of failures and turning things off, let's do a bit of a demonstration about the system's fidelity. We set up a demo for Flight Sim Expo 2023 to indicate that we wanted certain components to fail. The actual failures menu for the extended simulation package will not be done like this. This is purely for demonstration purposes. However, let's give it a try. We have System 2 in the hydraulic system normally functioning right now. Let's see what happens if we fail it. We now see the indications change. We see that we have low pressure even though the pump is on. So in a situation like this, we now have a pump fault. Now this light would actually help us. In this condition, the aircraft doesn't think that it needs pressure on System 2, which is why it hasn't opened up any of the transfer pumps. If we wanted to have pressure on System 2, despite the aircraft not feeling it's necessary, we can revert the system to manual mode and manually transfer pressure from either System 1 or 3. There we go. We've now managed to restore pressure. So we've overcome a failed hydraulic system. Both pumps failed. We've been able to overcome that and retain pressure to the hydraulic system. This level of fidelity is demonstrated throughout the entire aircraft. But let's reset everything back to normal for now. Of course, this video wouldn't be complete without some discussion of the variations of this aircraft at both the micro and macro level. At the macro level, we have the passenger, cargo, and ER variant, with the ER being exclusive to the Collector's Edition owners. This aircraft in this video is a passenger version, but we do have the cargo version as well. We are still working on some of the changes required for the cargo version, as the focus was on passenger first, getting the systems done, and then focusing on the changes. However, we had the opportunity to discuss some really cool things we can do with the cargo system, such as dynamic cargo or maybe even varied, or potentially even custom cargo objects. We've got some of those things on the horizon that we want to really evaluate on our side and then see what we can do to make the cargo operations more in-depth. But we'll focus on that in another video. In general, we're trying to get a solid amount of the customer options that this aircraft shipped with available. A small demonstration of this is the tape displays on the EAD. This was very specific to a certain carrier, but if your carrier wasn't that carrier, you can also switch it back to the dials. There are a number of other options in the aircraft like this, all the way from major components like the EAD to something minor like the weight and balance system. Certain aircraft had the ability to automatically sense their weight, which is shown in this column here on the init page in the MCDU. If your carrier did not opt for this, you won't have those options. This is just one of the small variations you're going to have. There are others. As I mentioned earlier, this is a passenger aircraft. So in addition to the fully modeled 3D cockpit, we also have a passenger cabin. So I'm going to slide through the cockpit door here and take a look. Now, this is again a work in progress version, so there are some visual issues, and it's also quite dark. It won't be left that way. But this is something you can do during your flights. You'll be able to walk back through the cabin if you're simulating a historic passenger flight and actually see the inside of the plane. Our goal is immersion with this project. As you've seen from the systems demonstration today, we are quite far along, but I want to talk a little bit about the time it took to get here and what we can expect going forward. Up till this point, the in-sim previews have been limited because we spend the majority of the time working on systems logic outside of the sim. Now, what does that mean? It means we don't have to wait for the sim to load. We don't have to switch aircraft. We don't have to fight with anything if there's a crash. We just try again. It means we can develop much, much faster. That code, when we're done, goes straight into the simulator. It does not run as an external application. It means no extra programs to run, and we have greater compatibility with other marketplace options or potentially other platforms. What we can expect from here is to go from where we are today to ideally a flyable state within the next couple of months. Now, what does flyable mean? This aircraft here does have a lot of its onboard systems, but as you can see from the demo in the cockpit, there are certainly elements that are missing. We expect to see those elements come online in the next couple of weeks and get the aircraft to the point that it can do a gate-to-gate flight without any major obvious missing components here relatively soon. With the exception, of course, of the elephant in the room, sound. We are working with Turbine Sound Studios to create high-fidelity sound packs specifically for this aircraft. It is not currently implemented, which is why you don't hear anything. We have, however, worked with MD-11 professionals to collect resources and sounds from the actual cockpit to give us our cause alerts and other system alerts. So we should be expecting to see sounds come online here similarly within the next few months or sooner. Finally, just some little housekeeping items such as CPDLC, ACARS integration, EFB, things like that. Yes, to all of the things that I just said. This aircraft will have those. We intend to integrate with Smart Cars 3 to allow native operations with airlines. We will have CPDLC communication with online network providers, the exact details of which have yet to be announced. And of course, we will have an EFB. Our 717 was one of the first aircraft to have a tablet in the cockpit in the simulator. Since then, we've seen a lot of amazing things done by the developers. We intend to learn from what has succeeded our initial tablet and create something compelling and easy to use in the cockpit. Similar to the cargo system, that'll be a system worthy of its own video as we get there, but I wanted to touch on it. Finally, if you'd like to follow development status, whether you're a pre-order customer or not, you can go to md11.tfdidesign.com to see weekly updates on exactly where the project is, what state we're working toward, what condition the aircraft is in, and once we've started distributing early access versions to our customers, you'll be able to get an indication of what level of stability you should be expecting so you can control when you join the early access process. As always, we thank you for your support and for watching this video. We hope this gives some updates on the project, and we look forward to seeing it in the skies and in your hands as soon as possible.